These are Year 14 past paper questions from 2004, and it'll take you up to 2008. And these are on nuclear decay. So this is from A2 Physics 4, and this is nuclear decay. Right, the first question is from June 2004 from Module 6 Particle Physics. So that was the old Module 6. And it gives you a data, an equation. And the equation you should recognise is for the equation to calculate the radius of a nucleus. So the first question says then, in equation 1.1, what does the symbol A represent? So the symbol A is obviously the atomic mass number. And you'd be okay saying there the number of protons plus the number of neutrons, but in its proper title is atomic mass number. Describe the structure of an atom of aluminium-27, and it gives you the numbers 27, 13 in terms of protons, neutrons and electrons. Now when they say structure, they're looking for not only how many of each kind of particle there are, but where they're also found. And so you've got 27 atomic mass numbers. That's 27 protons plus 27 neutrons, and where are they found? They're found in the nucleus. 27 protons and neutrons, should I say, and they're found in the nucleus. Now, you can be even more specific than that, and you should be more specific than that and give their actual numbers. So you know that there are 13 protons. So there's 13 protons, and then 13 away from 27 gives you 14 neutrons found in the nucleus of the atom. So that is a better answer there than this one here, because we haven't been specific enough about protons and neutrons. And then the last part, how many electrons? So that if there's 13 protons and it's a neutral atom, then there's going to be 13 electrons, but they're found outside the nucleus in the shells. Okay, the next question then says, use the equation to find the radius of an aluminium-27 nucleus. Take R0 as 1.2 femtometers. So 1.2 femtometers is by 10 to the minus 15 meters. And so R is equal to, R0 then is the radius of the nucleons. So it's 1.2 by 10 to the minus 15. And that's multiplied by the atomic number, and it's cube rooted, so it's 27 to the power of a third. And when you do that, that answer comes out as 3.6 by 10 to the minus 15, or 3.6 femtometers. I'm putting in there. Okay, so 3.6 femtometers. Right, it now says use your answer to part 2 to find the density of an aluminium-27 nucleus. The mass of the aluminium-27 nucleus is 26.98 unified atomic mass units. Assume the nucleus to be spherical. So we know that density is mass over volume. So I've got that written here. And the mass we're given is 26.98 units. And we have to convert that to kilograms. So use the data on your formula sheet. And so the mass of the nucleus is 26.98 multiplied by 1.66 is the conversion by 10 to the minus 27. That's the value in kilograms of the mass of an atomic unit. Then the volume is the volume of a sphere, which is 4/3 pi r cubed. And we're using 4/3 pi, and then the r that we're using is the 3.6 femtometers, so it's by 10 to the minus 15 all cubed. And that answer comes out to be 2.29 by 10 to the 17, or you could round that up to 2.3 by 10 to the 17. So that's an absolutely massive density, 2.3 by 10 to the 17. Your answer should be many orders of magnitude greater than the density of a typical solid. So if you think about the density of something like lead would be 8,000 kilograms per metre cubed. So that's 8 by 10 to the 3. So this is a massive number of times bigger. And the reason is because most substances are made up of empty space. whereas the density of the nucleus is really massive. The protons and neutrons are packed so tightly together, whereas most of the things we look around us are actually mostly made up of free space.